Okay, so here we're going to write down the matrix for -3, -22, -2, -5, -28. And what we want is to make that number a 0. So I'm going to do row 1 plus 2 times row 2. So I get a 0 here. And then it's -3 plus 2 times -5. That's -13. And then it's -22 plus 2 times -28, which is -78. The first row remains unchanged. And then when I divide row 2 by -13, row 1 still remains unchanged. And I get 0, 1, 6. And that's pretty much what I want. So it's triangular form instead of row echelon, right? I just want, everything under that main diagonal to be 0. So from here, I get that y is equal to 6. And then when I plug it into the other equation, 4x minus 3y equals -22. And we solve, x ends up being -1. So this is -1 comma 6, which is B. All right, for the next one, we need a little bit more space. So let me get another piece of paper here. All right, so first we write down the matrix. It's -4, 2, -1, 17, 1 minus 3, 2 minus 16, 2, 1 minus 4, 4. Okay, so first, I want to make this one a 0, right? To do that, I want to do 2 row 2 minus row 3. Okay, and if that's the one that I want to make 0, that's the only row that I change. Okay, so if I do 2 row 2 minus that one, I get a 0 here. And then 2 times -3, that's -6. Minus 1, that's -7. And then 2 times 2, 4. Minus -4 is 8. And then here, 2 times -16 minus 4 is -36. Okay, next, what I want is I want to make that 1 a 0. For that one, I want to do row 1 plus 4 times row 2. So here I get a 0, and then 2 minus 12 is -10. Row 1, -1 plus 4 times 2 is 8, so that's 7. And here 17 minus 4 times 16, that's -47. Okay, the first row will remain unchanged. -4, +2, -1, 17. All right, next I want to change this one, right? To do that, the first row again will remain unchanged. And let's copy down the second row either because I'm not going to change it. Okay, that last row, to change that one, I want to do 7 times row 2 minus 10 times row 3. Okay? So I get 0, 0, and then 7 times 7 is 49, minus 80, that's -31, and then 7 times -47, minus 10 times that gives you a 31. Okay. You can plug these numbers into your calculator on the test as long as you show me the work, right? All the bookkeeping. All right, next, -4, 2, -1, 17, 0, -10, 7, -47. And then here, I want to divide row 3 by -31. So I get 0, 0, 1, minus 1. Okay, this is triangular form. For true row echelon form, these coefficients, like the -4 and the -10, would also have to be divided out to make it a 1, but I'm not requiring you to do that because there's no point this year, okay? So from here, I get that z is equal to -1. And then from row 2, -10y plus 7z is -47. So -10y plus 7 times -1 is -47. When you solve that, y is 4. Finally, -4x plus 2y minus z is 17. And plugging in everything that we've solved for, that gives us x equal to -2. So this is -2, 4, -1, and that is -2, 4, and -1 is h. Okay, which of the following matrices is singular? Singular means determinant equals 0 and inverse doesn't exist, right? So you just basically have to go and see, does this give you a 0? Well, that's 0 minus -1. Nope. This one, 28. This one, -4. When you subtract them, that's not 0. 8, -15. Nope. What about this one, -12, -12? When you subtract those, you do get 0, so it's D. All right, one more. Augmented matrices to solve this system. Okay, so here I have -4, -2, -14, -8, -4, 4. Okay, notice we can simplify both of these equations, right? So I can divide row 1 by 2. And I could divide row 2 by 4. And I get -1. I'm sorry, by 2, -2. Ugh. Oh, yeah, you know what? Why don't we just divide by -2? So I get 2, 1, 7. And here, if I divide by 4, I get -2, -1, 1. Okay? All right, so next, I want to get rid of this one. So why don't I do row 1 plus row 2? So I get 0, 0, 8. Okay, and that's a problem because here it says that 0 is equal to 8, and that's not possible, so it's no solution. Okay, Katie bought 4 apples and 6 pears for $9.80. Sylvia bought 3 apples and 9 pears for $10.95. Write a set of linear equations for this situation. All right, so Katie bought 4 apples plus 6 pears for $9.80. Sylvia bought 3 apples plus 9 pears for $10.95. So that's what you put here. Okay, that's it. It's just a system of equations. That's it. And now it says convert to augmented matrices and solve. Okay, so 4, 6, 9.8, 3, 9, 10.95. Definitely need a calculator here, right? Okay, so I want to make this one a 0. So what are we going to do? 3R1 minus 4R2. So here that's not changing. We could have divided that by 2. I'm just going to leave it for now. Okay, here 3R1 minus 4R2, that gives you a 0. And then here I have 3 times 6 minus 4 times 9. That gives me -18. And for the last one, I have 3 times 9.8 minus 4 times 10.95, -14.4. Okay. And then So when we divide row 2 by negative 18, I get 4, 6, 9.8, 0, 1, and then what do we get there? Negative 14.4 divided by negative 18, 0.8. Okay, so what does that tell you? Remember, these are A's and P's, right? This tells you that P is 0.8, and then 4A plus 6P is 9.8. Plug in the P, and you get that A is equal to 1.25. What does that mean? An apple costs $1.25, and a pear costs 80 cents. Okay, here we go. Determinant. We're going to copy down the first two columns. All right, and then this diagonal, that diagonal. And the first diagonal, the product is a 1. Plus another 1, plus the last diagonal, the product is 0. And then in the other direction, they're going to be minuses. So minus 0, minus 1, minus 1. Okay, so we have positive 2, negative 2, that's 0. Oh, look, another singular matrix. Okay, find AB if it's possible. Well, let's see if it is possible. The first one is a, 1 second, sorry, I want to exit out of there. Okay, the first one is a 3 by 3, and this is a 3 by 1. So yes, it's possible, and the solution will be a 3 by 1. So when I write these down here, okay, I'm going to get a 3 by 1. Okay, 3 rows, 1 column. Okay. And the first one, right, this is row 1, column 1. So I take row 1 with column 1, and I multiply first number with first number, so that's 4. 3 times 1, so plus 3, plus 2 times negative 2, negative 4. Second, I want to do row 2, or sorry, row 2, column 1, yes. So row 2 with column 1. First number with first number is 0, plus negative 1 times 1, minus 2. And then lastly, I get row 3, column 1, row 3, column 1. First number with first number is 2, plus second number with second number, right? We're getting the product. 1 times 1 is 1, plus last number times last number is negative 6. And then that gives me 3, negative 3, negative 3. Although I feel like that should be a positive 3. Okay. Okay, so that, it is negative 3, by the way. Sorry, I didn't mean to leave you hanging. 3, negative 3, negative 3. All right, and that's that.